Welcome to G Fun Facts Online. Today, we're journeying back in time. Not just a few thousand years, but 310 million years. To a world so alien, it might as well be another planet. We're going to a time when a fish, in the murky, primeval swamps, evolved a secret weapon, a hidden, second set of jaws in its throat, a deadly mechanism that scientists have dubbed a tongue bite. This discovery hasn't just introduced us to a fascinating ancient predator. It has fundamentally rewritten a chapter in the evolution of all vertebrates. So let's dive into the Carboniferous period and meet the fish with the killer tongue. Our story begins not in the water, but locked away in a piece of rock unearthed in Staffordshire, UK. This fossil, of a creature named Platysomus parvulus, is our time capsule. It dates back to the Carboniferous period, an era stretching from 359 to 299 million years ago. To understand our fish, we first need to understand its world. Forget the Earth, you know. During the Carboniferous, the planet's continents were slowly crunching together to form the single, colossal supercontinent of Pangaea. The spot where our fossil was found, now in the UK, was then located near the equator. The climate was hot, humid, and tropical. And I mean tropical on a scale we can barely imagine. This period is famous for its vast, lush coal forests. These weren't forests of pine and oak, but of gigantic club mosses, towering 100 feet into the air, and colossal horsetails. The air itself was different, with oxygen levels estimated to be as high as 35%, compared to our 21% today. This oxygen-rich atmosphere fueled gigantism, especially in insects. Imagine dragonflies with the wingspan of a modern hawk, some up to 2 feet across. Millipedes, 6 feet long, crawled across the forest floor. The world was a greenhouse picturesque with swamps, winding river channels, and shallow, shifting seas. On land, the first great empires of four-legged animals were rising. Early amphibians, some the size of crocodiles, were the dominant land predators. And tucked away in the undergrowth, the very first reptiles were making their appearance, a pivotal moment that would eventually lead to the age of dinosaurs, and even to us mammals. But the seas and rivers were where the action was for our story. This was a time of evolutionary explosion. The planet was still recovering from a major catastrophe, the late Devonian mass extinction. This event had wiped out a huge number of marine species, including the heavily armored, jawless fish and the monstrous placoderms, like the car-sized Dunkleosteus. With these apex predators gone, the oceans were full of empty jobs, ecological niches just waiting to be filled, and the survivors, particularly a group called the ray-finned fishes, rushed to fill them. They diversified gull, experimenting with new body shapes, new lifestyles, and, crucially, new ways to eat. It was in this crucible of evolutionary innovation, this dynamic and dangerous world, that Platysomus parvulus carved out its existence. Outwardly, Platysomus wasn't necessarily a showstopper. It was a deep-bodied fish, meaning it was taller than it was long, kind of like a modern-day sunfish or angelfish. This shape is good for maneuverability in complex environments, like weedy swamps or reefs, but not for outright speed. It probably looked like many other fish of its time. But the secret, the thing that makes it so extraordinary, was hidden inside its mouth. For a long time, we thought we had a pretty good handle on how early fish ate. They used their primary jaws, the ones at the front of their face, to grab, bite, and maybe do some simple processing of their food. But Platysomus was doing something far more sophisticated. An international team of scientists, curious about this well-preserved fossil, decided to look inside without breaking the rock. They used high-resolution computed tomography, or CT scanning. It's the same technology hospitals use to see inside a human body, but cranked up to a much higher resolution to peer into solid rock. By taking thousands of X-ray slices, they could build a perfect digital, three-dimensional model of the fish's skull and all its delicate internal bones. And that's when they saw it. Platysomus parvulus had a second set of jaws. not on its face, but deep inside its throat, on the floor and roof of its mouth. This tongue bite apparatus was an intricate piece of biological machinery. On the floor of its mouth, built into its gill skeleton, was a complex plate, armed with teeth. This plate could move upwards, slamming against another toothy field on the roof of its mouth. In effect, it had a crushing, piercing platform hidden in its throat. This wasn't just a simple set of throat teeth. It was a multi-partite, coordinated system, a true second jaw. This mechanism allowed Platysomus to do something many of its contemporaries couldn't: process hard-shelled prey. While other fish were limited to swallowing their food whole or taking simple bites, Platysomus could grab prey with its front jaws, then pass it back to this powerful internal apparatus to be pierced and crushed. Its diet likely consisted of tough morsels like crustaceans, or perhaps some of those giant insects that unfortunately fell from the branches above into the water. This was a game changer. It opened up a whole new menu. The discovery was stunning, not just because of the mechanism itself, but because of its age. Scientists knew that other, later fish had evolved this kind of tongue bite. But this fossil, at 310 million years old, pushed back the known origin of this complex feeding strategy in ray-finned fish by an incredible 150 million years. That's a staggering leap back in time. It's like finding a blueprint for a steam engine in the ruins of ancient Rome. It forces a complete re-evaluation of the timeline. So this tongue bite is more than just a cool, deadly party trick. It represents a crucial evolutionary stepping stone. Professor Sam Giles of the University of Birmingham, the study's lead author, points out that tongue bites have actually evolved independently many times in different fish lineages. We see them in modern fish like trout and bonefish. This is a classic case of convergent evolution, when nature arrives at the same solution to a problem multiple times. The problem was how to eat a wider variety of food, and the tongue bite was a very successful answer. Platysomus, however, seems to be caught right in the middle of this evolutionary transition. It's what Dr. Matthew Coleman, a co-author from the University of Louisville, describes as a missing link. It bridges the gap between simpler jawed fish and the more advanced, specialized tongue biters that came later. Here's how that transition worked. Platysomus had a dual system. It still used its primary external jaws for more than just grabbing, but it also had this new, internal tongue bite. It was a versatile generalist. Now, contrast this with a later group of fish, like one called Bobacitrenia, which lived millions of years later. By the time Bobacitrenia was around, the tongue bite had become even more advanced. These later fish had lost the teeth on their primary jaws. Their mouths had become specialized tools for one thing only: sucking in water and prey. All the work of chewing, crushing, and processing was offloaded entirely to their highly developed internal tongue bite. Platysomus shows us the in-between stage. Its tongue bite was more primitive than what came later. The scans revealed its lower tooth plate was made of multiple, separate pieces, not one solid, fused crusher. And the teeth themselves, on both the upper and lower plates, were a single layer of sharp, pointed cones. This setup was good for gripping and piercing, but not for the kind of heavy-duty, molar-like crushing that later species with consolidated, multi-layered tooth plates would achieve. It was a prototype, version 1.0 of the tongue bite, and its existence tells us something profound about the pace of evolution. The aftermath of the Devonian mass extinction wasn't an instantaneous explosion of new, perfectly formed creatures. As co-author Professor Matt Friedman from the University of Michigan notes, the tongue bite was just one of many feeding innovations that emerged during the Carboniferous. Fish were experimenting. It was a period of trial and error. This discovery strongly supports what's known as a long fuse model of diversification. Evolution isn't always a sudden bang. Sometimes, it's a slow burn. The fuse for this particular innovation, the tongue bite, was lit 310 million years ago with fish like Platysomus, but it took millions more years for that fuse to burn, for the trait to be refined, specialized, and perfected in later lineages. It shows that major evolutionary novelties can have very deep, very ancient roots. A feature that becomes dominant in one era might have first appeared in a much more humble, primitive form tens of millions of years earlier. Platysomus parvulus, this deep-bodied fish from a long-lost world, is a perfect illustration of this. It was an experiment, a successful one, that paved the way for future generations. It survived and thrived in the chaotic, opportunity-rich world after a mass extinction by developing a secret weapon, a way to exploit food sources its competitors couldn't touch. Its story is a powerful reminder that evolution is not a linear march towards a predetermined goal. It's a vast, branching tree of experiments, a tapestry of innovations, successes, and dead ends. And sometimes, the most significant leaps forward, the ones that rewrite our understanding of the history of life, happen quietly, deep within the mouth of a seemingly ordinary fish 310 million years ago. Thanks for listening to G Fun Facts Online.